Welcome back viewers. Let's discuss about network topology. Network topology is a graphical representation of electric circuit. It is useful for analyzing complex electric circuits. The different terminologies used in graph theory are node, degree of a node, branches, linear graph, oriented and unoriented graph, connected and unconnected graph, planar and non-planar graph, subgraph, paths, trees, twigs, links, loop. Let's see the brief of these network terminologies. Nodes are the endpoints of branches or point of intersection of two or more branches. Let us consider this circuit diagram. Here we can say that this is node A, and then end of this branch is node B, and then we can say this is node C because this is end of this R3 resistor, node C. Next, here end of this R5 is this node, and then here capacitor also same node. Voltage also 3 elements are connected in same common point. We can say that this is node D. Next, degree of a node. The number of branches incident or connected to each. Branches incident in a node is called degree of a node. Here we can say this is node A, and then degree of a node of this node A is 3 because 3 are connected. This is one branch, this is second branch, this is third branch. Here for this node A, degree of branch is 3. 3 branches are incident in this node A. Next one is branches. Branch is a line joining two nodes which represents a circuit element. Branch means circuit element is represented as a branch. Here this is one branch. This resistor is called another branch. This is also another branch. Next is the linear graph. Linear graph is defined as a collection of various nodes and branches. Initially I told network topology is the graphical representation of circuit. Here this is the circuit diagram. We have to convert this circuit into graph. This is the linear graph. Linear graph means it contains nodes and branches. In this graph, internal impedance of an ideal voltage is 0 and hence it is replaced by short circuit. Voltage is replaced by short circuit. Internal impedance of an ideal current source is infinite and it is replaced by an open circuit. Consider this circuit diagram. Here this voltage is series with the resistance. We can short this voltage. We have to convert this voltage into single branch. This is the branch. We know that branch means circuit element. We have to convert this circuit into this linear graph. Just we have to mark the node A, B, C, D. Next we have to draw the branches of this graph. Branch means circuit elements. Instead of this resistor, we have to draw one line. And then instead of this resistor R3, we have to draw another line, that is called branch. Next here, this is voltage. We have to short this voltage, and then resistor also we have to draw one single line. If the resistor is series with this voltage source, we can consider as single branch. We have to draw the single branch. And then here also voltage is series with the resistance. We can consider as single branch. Next here this is resistance and here it is having one current source. Current means we know that open circuit. Just we have to remove this one, draw as a single this resistor branch line. Here we have to, before we have to put the value of the branch. Here consider this is 1, this is 2. Anyway we have to consider the values of this branch. Here 1, 2, 3, 4, 5, 6. These all are the branches of this graph. Next, oriented and unoriented graph. From the name itself, we can say that oriented is also called as directed or oriented graph. When all nodes and branches are numbered and directions are assigned to branches by using arrows. This graph contains the direction, branch values and the direction. So this graph is called oriented graph. If the graph is having direction means the graph is said to be oriented graph. Otherwise it is called unoriented graph. This graph contains there is no direction. So it is called unoriented graph. Next one is connected and unconnected graph. In between every pair of nodes of a graph, there is at least one path along with branches exists is called connected graph. Consider this graph here between A and C. Here it is having one node. Between any node, intermediate node is present means which is called connected graph. Otherwise it is called unconnected graph. Here there is no intermediate path. This graph is called unconnected graph. Here also any other intermediate path, we can say that this is unconnected graph. Next one is planar and non-planar graph. Planar is a graph is a planar if it can be drawn in a plane such that no two branches intersects at a point which is not a node. Here any other intersections of these branches is called the planar graph. Here this graph is having some intersection which is called non-planar graph. Next one is subgraph. A subgraph is a subset of nodes and branches of a graph. Subset of nodes and branches of a graph. The subgraph is said to be proper if it has number of nodes and branches strictly less than that of the original graph. Otherwise, it is called improper graph. Let's see the example. This is the unoriented graph. Here, subgraph means it should be less than the original graph nodes and branches. Here, this graph is having totally 6 branches and then 4 nodes. This is the proper subgraph because it is having less number of branches and less number of nodes than the original graph. But here this is the improper subgraph because it is having same nodes, because the original graph is having 4 nodes. Here this is also having same nodes. So that it is improper graph, subgraph, because we know that it should be less than the number of nodes and branches is less than the original graph. Path. Path is a particular subgraph where only 2 branches are incident at every node except the internal node. Here starting and ending nodes, it is having only a single connection. Remaining nodes are having 2 branches intersection, but the starting and ending nodes are having a single connection which is called path. Path, it does not contain any closed path. This is the open path, open loop. Next one is the tree. Tree is a connected subgraph of a connected graph having all the nodes of the graph but without any closed path. In this tree, all the nodes are present but there is any closed path, that is called tree. Consider this diagram. This is the graph and then we have to draw the tree of this graph means just we have to mark all the nodes of this graph and next it does not contain any closed path. We can draw this as tree of this graph or else we can draw this is the tree of the original graph. Anyway, we can choose the tree of this graph because the condition is all the nodes are present but there is any closed path. Next, properties of a tree. In a tree, there exists one and only one path between any pairs of nodes. Every connected graph has at least one tree. Each graph is having at least one tree. There is no closed path. Initially I told There is no closed path in a tree, hence there is circuitless. The rank of the tree is calculated by n minus 1. N is the number of nodes. The rank of the tree we can calculate it by n minus 1. For this graph, we can calculate the rank of the tree is n minus 1. That is 4 minus 1 equal to 3. The rank of this graph is 3 because the nodes are 1, 2, 3, 4. The rank of the tree is n minus 1. 4 minus 1 equal to 3. Next, twigs. Twigs is also called as tree branches. Tree branches can be calculated by same n minus 1 because branches of the tree is called twigs. Next one is the links and core tree. Links and core tree is called the remaining branches of the tree is called links and core tree. Here the number of links can be calculated by b minus n plus 1. The number of links calculated by b minus n plus 1. B is the number of branches of the graph. N is the number of nodes of the graph. Consider this graph. Here let us choose this graph as the tree. Then remaining branches are this 5, this 1, this 6. We can say the links of this graph is 3. This is called links and core tree. We can calculate it by using this equation b minus n plus 1. Next, loop. A loop is a complete path. We know that loop means complete path. It should be starts a selected node, traces a set of connected basic circuit elements and returns to the original starting point. It should be started in a particular node and also ended with the same starting node. Properties of loop. There exist at least 2 branches in a loop. At least 2 branches in a loop. The maximum possible branches in a loop are equal to the number of nodes. Branches, it should be equal to the number of nodes. There are exactly 2 paths between any pairs of nodes in the circuit. Next topic is incidence matrix. Incidence matrix is the matrix which represents the graph such that with the help of that matrix we can draw a graph. This matrix can be denoted as A suffix C. The rows of the matrix AC represents the number of nodes. The rows can be represented as nodes and the column of the matrix can be represented as branches. Here the conditions of this incidence matrix is these 3 points. First one is outgoing branch from kth node we can represent it as +1. Incoming branch is represented as -1. Others we can represent it as 0. Let's see this example. Here consider this graph. We have to write the incidence matrix. From this graph we can say that it is having 4 nodes because this dot is the node A, B, C, D. It is having 4 nodes and also it is having 6 branches because it is having 6 lines. 1, 2, 3, 4, 5, 6. We can say this graph is having 4 nodes and 6 branches. We have to write the incidence matrix. We know that rows represents the nodes and then column represents the branches. We have to write the nodes A, B, C, D in the row and then columns we know that 6 branches. We have to write the branches. Here the condition is consider this node A. First we have to consider the node A. The condition is outgoing branch is represented as +1. Here this one is, this arrow is away from the node, that is outgoing from this node. We can say outgoing branch as +1. For that we have to mark this A, the branch value 1, we can mark this as +1 because the branch is away from the node. We can away from the node means we have to put +1. Next, consider the same node A. This second branch arrow is towards the node. We can write -1. Towards means minus, away means plus. Again, one more branch is also having node A. Here, this is away from the node. The branch value is 5. For 5, we can write +1 because the value is away. Remaining, there is no connection. We can simply put 0. Next, consider node B. Here, in this node B, this one is incoming towards the B, node B. We can put -1. Here, we can, for this branch 1, we can put -1 because towards the node. Next, 3 is also towards the node. We can put minus. For this 3, here we can write -1. And then next branch is 6. 6 is also towards the node. We can put 46 minus, remaining the values are 0. Similarly, we can write the node C. Here C, the branches are 4, 5, 6. This 4 is away from the node. We can write the 4 value is +1 because away from the node. Then 5 is towards the node. We can put minus. Then 6 is away from the node. We can put +1. Remaining values are 0. D also, here these 3 and 2 are away from the node. We can write it 2 and 3 are +1, +1. Next, this 4 is towards the node. We can put minus. Remaining, there is no branches. We can put 0. This is the incidence matrix. Next, we have to write the reduced incidence matrix. Reduced incidence matrix, we have to reduce the last row. In this matrix, we have to reduce the last row of this matrix. This is called the reduced incidence matrix. And also one more thing, we can find whether our answer is correct or wrong. How we can find means sum of these column value, it should be 0. +1 -1 equal to 0. -1 +1 equal to 0. Minus sum of these column values, it should be 0. +1 -1 equal to 0. +1 -1 equal to 0. -1 +1 equal to 0. -1 +1 equal to 0. The sum of each column value, it should be 0. Next, reduced incidence matrix means just we have to reduce the last row. This is the reduced incidence matrix. The order is n-1 cross B. Here n-1, previous one is 4 nodes. 4 minus 1 equal to 3. 3 cross B. Branches also same. Branches also 6. Branches are same, but the node is reduced to 3. Next, properties of incidence matrix. Each column representing a branch contains 2 non-zero +1 and -1, the rest being 0. Here we know that this column is contain only 2 values, +1, -1. Here also in this incidence matrix, here also +1, -1, -1 plus, here -1 plus, +1, -1, -1, +1, +1, -1. Only it is having 2 values. Each column is having 2 values in the incidence matrix. This is the properties of incidence matrix. Next, the unit entries in a row identify the branches incident at a node. We know that branches incident at a node is called degree of the node. In this incidence matrix for this node A, the degree of nodes are 1, 2, 3. This value represents the degree of nodes because it is having 3 values, +1, -1, +1. It is having, this node A is having 3 degree of node. This B is having 3. This C is having 3. This D is also having same 3 because it is having 3 values. So the degree of node is 3. This is the properties of incidence matrix. Next, incidence matrix and KCL. The reduced incidence matrix can be expressed in terms of KCL, Kirchhoff's current law, as AI equal to 0. This A represents the reduced incidence matrix. I represents the branch current vectors. If the graph is having 6 branch means the current values are I1, I2, I3, I4, I5 till I6. Consider this graph. Here this is the incidence matrix of this graph. Here it is having A, B, C, D. It is having 4 nodes. This is the reduced incidence matrix because it is having 4 but it is having 3. KCL expressed incidence matrix expressed in KCL, we have to consider the reduced incidence matrix. For that we have to write the reduced incidence matrix A into I. I is the branch current till I1 to I6 equal to 0. From that we can get the KCL equation as this row into this column. We can get minus I1 remaining 0, this value plus I4 equal to 0. Similarly, next row into this column, this value minus I2 minus I4 plus I5 equal to 0. Similarly, third row into this column, we can get the value equation minus I3 minus I5 minus I6 equal to 0. Next, the number of possible trees of a graph is equal to the determinants of the product of reduced incidence matrix A and its transpose A transpose. We can calculate number of possible tree equal to determinant of A into A transpose. Let's see the problems. First problem. Draw the graph of the networks for the given circuit and oriented graph. We have to draw the graph of this circuit. For that, first solution, we have to mark the nodes of the circuit. This is node A, this is node B, this is node C, this is node D. We have to mark the nodes of the circuit. Next, we have to mark the value. Here it is having current. We know that current means open. This will be 0. No need to mark this value. Here this element is 1. This is 2. This is 3. This is 4. This is 5. Because voltage means short. It is having branch connection. For that we have to mark the value. Anyway, we can mark the value. Here we have marked the capacitor as 1, resistor R1 as 2, inductance 3, R2 as 4, E1 voltage as 5. Next we have to replace the circuit by using this graph. Here just we have to mark the node A, B, this C, this D. First we have to mark the node. Next we have to convert this element into single line, that is branch. This is first branch, next second branch, then third, fourth, fifth. And then anyway we have to mark the direction of this branch. This direction represents the current flow direction. Anyway we can mark the direction of this graph. This is the oriented graph. We got the answer. Next problem. Obtain the reduced incidence matrix of the given networks. We have to find the reduced incidence matrix. Here this is the circuit diagram. We have to find the reduced incidence matrix. For that we have to create the oriented graph. We know that this is the current. We have to open this one. This is the voltage. We have to short this one. Before we have to mark the node. This is node here. This is node A. This is node A. Anyway we can mark the node. Let us consider this is node A. This is node B. This is node C. This is node D. It is having 4 nodes. First we have to mark the node. Next we have to draw the branches. This is one branch. Consider this is 4. This is the next we have to mark the value 1, 2, 3, 4, 5. And then this will be the 6. Voltage will be the 6. Just we have to replace the components by a single line. This is one line. This is one line. Here no need to draw this one because this is current. We have to open this one. No need to draw this one. Next this 3, 5 and 6. Anyway we have to put the direction. This is the oriented graph. Next we have to find the incidence matrix. Next we have to obtain the incidence. Not this reduced incidence matrix. we have to obtain the incidence matrix. We know that incidence matrix, first in the row we have to mark the nodes A, B, C, D. Next branches, it is having 6 branches. Next consider this node A. In this node A, one branch current is leaving and another one is also leaving. Both the directions are leaving from the node. For that we have to put +1. For 1 we can put +1. For 4 also we can put +1. Remaining there is no connection, we can put 0. Next consider B. 4 is incoming, we can put -1. For this 4 we can put -1. And then 3 also incoming, we can put for 3 -1. Next 5 and 6. All the branches are incoming. We can put all the values are minus, remaining 0. Next C, here 2 is incoming. For 2 we can put -1. Then 5 is leaving. We can put +1. 6 is also leaving, +1. Similarly for D, in this D, 1 is incoming. Incoming we put minus. 2 and 3 are outgoing. We can put plus, remaining 0. This is the incidence matrix. Next we have to write the reduced incidence matrix. For that just we have to remove the last row. Remaining is the reduced incidence matrix. Next problem, obtain the linear graph for the given incidence matrix. A matrix is given. Also find the number of possible trees. First we have to draw the graph. For that first we have to check whether our matrix is incidence matrix or reduced incidence matrix. How we can check means we have to add the column. If it is 0 means we know that this is the incidence matrix, otherwise reduced incidence matrix. First we have to check +1 -1 0, -1 +1 0. Next column +1, there is no -1 value. Here we got the answer is +1. We can say that this is the reduced incidence matrix because we can't get the 0 value in this third column. For that first we have to write the complete incidence matrix. First we have to write the complete incidence matrix. First fill the 3 rows. Next here it is 0, we can put 0. The sum of these two is 0, we can put 0. But here in the third column we didn't get the 0. If we put -1 means we can get the 0. For that here we can put the -1. Next column also +1. Next we have to put the -1. Here also we have to put -1. Here +1 -1 0. Here simply we can put the 0. This is the complete incidence matrix. Next we have to draw the oriented graph. How we can draw the oriented graph means first from the incidence matrix itself we know that it is having 4 nodes A, B, C, D. First we have to consider the node A. In this node A, here it is having first column first branch. The column values are +1 and -1. Node A and B. For that first we have to mark the node A. First branch value is, it is having B and A and B. A and B. First we have to mark the node A and B. Next we have to join this line. And then we know that in the oriented graph the arrow is towards means minus, away from the node means plus. Here B is having minus. We can put the arrow direction is towards the B node. First we have to mark the node AB because the branch 1. Consider the column. Column wise we have to draw the graph. Consider the first branch values are A and B +1 -1. Here towards the node means only minus. We can put in the B only we are having minus. We can put the arrow this. Consider the next second column. Here the values are, second branch values are B is plus 1, C is minus 1. We have to draw the line between B and C. Here mark this as C and then we have to draw the line between B and C. And then C is having minus 1. So the arrow will be this. Next column is C and D. Here we are having C but we don't have D value. Here we have to put D node, and next joining the C and D, joining the line C and D, the arrow here D is having minus. The arrow it should be in this direction. Consider the fourth column. Here B and D. Already we are having the node B and also D. Just we have to connect the line and then the value D value it is having minus 1. We can put the value is arrow is this direction. Next column, this fifth column, values are in this A and D. Already we are having the node A and D. Just connect the line and then D is having the minus 1. We can put the arrow this direction. Next last column is A and C. A and C is having the value. We can draw the line A and C, and the C value is minus. We can put the direction as this. This is the oriented graph. Next, calculate the number of possible trees. We know that number of possible tree equal to determinant of A into A transpose. We know that A is the reduced incidence matrix. In this reduced incidence matrix, just we have to remove the last row. This is the reduced incidence matrix. Here, next one is the A transpose of this reduced incidence matrix. Next, we have to multiply this matrix here. First row into first column, we got the answer 3. And then next first row into second column, we got the answer minus 1. Similarly, last row in first row into last column, we got the answer minus 1. Then second row, just we have to multiply the second row into this first, second, third column. We got the second row. Similarly, we can do the third row also. Next, we have to find the determinant. Determinant of this matrix, we got the answer 16. So, the number of possible tree of this graph is 16. Next problem, draw the graph corresponding to the given incidence matrix. From this matrix, we know that it is having 5 nodes A, B, C, D and E, and then branches are 1 to 8. First, we have to consider the first column. Here, the first column is having the values A equal to minus 1, E equal to plus 1. Here, first we have to mark the node A and E. A is the first node and then E is the last node. We have to mark here as E. Next, we have to draw the line and then the A value is minus 1. We can mark the arrow this direction because incoming direction is minus 1. Next column is B value is minus 1, E value is plus 1. Here already we marked the node E and then we have to mark the node B, and next we have to connect this B and E and we have to draw the direction towards this B because B is having minus 1. Next third column, C and E. C, we have to mark the C and then we have to draw the line and then towards the C because C is having minus 1. Next column, C and E. Again it is having C and E. Again it is having one connection. We can draw the branch like this. Next, this value, this C is also having the minus value. We can put the direction like this. Next column is this A and D. A and D. Already we marked the node. Next we have to mark the D node and then D is having the minus 1. We can put the arrow like this direction. Next node is C and D. C, already we marked the node C and D. Just we have to connect the line and then we have to put the direction towards C because C is having the minus 1. Next A and B. Here A and B, the direction B is having minus 1. We put the direction like this. Next last one, here B and C. Just we have to mark the B and C. The direction C is having -1. For that we can put the direction towards the C. This is the oriented graph. Obtain the incidence matrix from the following reduced incidence matrix and draw its graph. This is the reduced incidence matrix. We have to create the complete incidence matrix. It is having 2, 4, 5 rows. We have to create the 6 rows and then same 7 branches. First we have to check the first column value. Here sum of first column value, it should be 0 only, which satisfies the complete incidence matrix. First we have to check -1. Here there is no +1. For that we have to put the last value as +1. Then only the sum is 0. Second column, it is having the sum is 0. No need to put any value. Just we can put the 0. Here also sum is 0. Just we can put 0. Here also sum 0. Just we have to put 0. Here also sum is 0. Here also sum is 0. But the last one, it is having +1. We have to put -1. Then only the sum is 0. This is the incidence matrix. Next we have to draw the oriented graph. For that we have to first check the first column. In this first column, A is having -1, F is having +1. First we have to mark the A node and then this is the last node. Then only here we have to put the last node F and then join this node and then arrow it should be towards A, because A is having -1. Towards the node is -1. Next, second column value is A and B. For that we have to mark the B node and then the arrow it should be towards B, because B is having -1. Next column value is B and E. B and E. Here this is the second node and then this is the fifth node. For that here I am marking this E node and then just mark this line and then the arrow it should be towards E, because E is having -1. Next column B and C. Already we are having B. Just we have to mark C and then joining the nodes. And then the direction should be towards the C, because C is having -1. Next column C and D. Already C is having D, we have to mark and then we have to draw the line and then C is -1. For that towards the C node we have to put the direction. Next column D and E. Already we are having D and E. Just draw the line and then our arrow should be towards E. Next E and F. E and F is having connection. Then F is having minus sign. We have to put the direction like this. This is the oriented graph. Thank you. To get the notification for my next video, please subscribe and click on bell icon. Thank you.